Now let's move to our next topic, which is type promotion. This concept also we are going to learn first by implementation. Let's see the example. In this example, I have a class called method overloading 3, which is having overloaded display method. Every single display method is having different type of parameters. First method is having byte parameter, second is having short parameter, then int, then long, float, and double. Now I'm calling this display method and passing 10. Now the question is, this stand can be held in any of parameter here. It can be held in byte type of formal argument, or it can be held in short type of formal argument, or in int or long, float, double. Every single method formal argument can hold this actual argument value. Then which method is going to execute? As I already taught you in data type classification, that by default integer constants or integer literals are treated as int. That means by default this values data type will be considered as int type. That means this method is getting prioritized, and this method is going to execute, and it is going to say one parameter of int type number. Let's run this one, and you can see I'm getting this one as an outcome, right? Now the question is, let's suppose this method is not here, this is missing, then which method is getting priority now? So for that type of situations we have a concept called type promotion. Now try to understand how this type promotion works. When you are passing 10 parameter or any integer type of parameter, and the same type of parameter is missing in method overloading case, then that value will be automatically promote to the bigger type of container. So this tan is going to promote from int to long type, means this tan is now became long type, and then this long is going to claim that I am the most appropriate method which should be execute, and then this long display method is going to execute. Let me run this, and then you can see we are getting long type of method. Similarly, if the long is again missing, then by default this integer type of value which was promote earlier to long now again promote to float type, and then this time a float method will get execute. Similarly, if float is also missing, then again it will promote to double. So like that the promotion goes, and this is known as type promotion. You can see in the notes here as well. By default integer type of value will be promoted to long if int type of method will be missing. If long is missing, then it will be promoted to float. If float is missing, then it will promote to double. But always remember, the concept is of type promotion, not type demotion. That means if double is missing, then automatically the value will not be demote to byte or short, right? The promotion will goes like in the upwards direction only. You cannot demote the value towards backward direction towards byte or short type. Okay, so in that particular case, if I am keep promoting the value, and if finally the double is also missing, then this tan will again check for double, and double is missing, then it will start giving you error, right? So how you handle this type of situation, because tan can be hold in byte type of container and can also be hold in short type of container. In that particular type of case, you have to do explicit typecasting. You have to convert this tan either into byte or into short basis on your requirement, which functionality you want to execute. For example, I want to execute byte 1, then I am typecasting my value to byte, and if I change it again to short, then it will execute short type of method. So this is what type promotion is and how this type promotion works. Actually, type promotion is nothing but implicitly typecasting is happening here. And in certain case, when type demotion doesn't work, there they ask you to perform explicit typecasting. Typecasting is a concept which we are going to learn in upcoming classes. There we will learn implicit and explicit and further other type of typecastings. So for now, just stick with this rule of type promotion. Now let's move to the next implementation of type promotion. Here I have a class named with method overloading 4, and this class containing two display methods. First display method is taking int and double type of value, and next display method is taking double and int type of value. And then after I'm making the call of display method here by passing two integer type of values. When we are making call here for display method, it is going to validate whether this first display method is eligible for calling or not. It will check whether this 10 can be held in this integer type of variable. Yes, it can hold this value. Then after it will check for that next 10 can be held in double type of variable. Yes, it is going to be happen by type promotion internally, right? So this method is eligible for calling. But then second method will also start claiming that I can also get execute, because for the first integer type of parameter I can promote to double, and the second is already of int type. That means this method signature is also getting matched with the required method types, right? That means both methods are claiming to get execute, and then ambiguity will be there and error will come. So how to avoid that type of situation? In that particular type of case, you have to typecast a particular type of value for the method which you want to execute. For example, I want to execute first method. I'll say I want to convert this into double type specifically. So now I am writing at compile time itself that first parameter will be of int type and second parameter will be of double type. That means this method is claiming I am going to execute, and second method could not handle it, because for second value which is of double type cannot be demote to int type. It can only promote, but it cannot be demote. Type promotion is there, demotion is not there, and that's why the second method could not get execute and first method only get execute. So that type of situations you can handle by using typecasting, and this is another example of type promotion.